We live in a time of global transformation. The Energy Futures podcast explores how we can accelerate the expansion of clean energy technologies and reduce our reliance on fossil fuels. From heating and cooling our homes to moving around our planet and beyond, we bring together researchers, scientists, business leaders and communicators to exchange knowledge and try to answer one important question. How can we create a sustainable energy future for all? This podcast is produced by Energy Futures Lab of Imperial College London.
This week we're joined by Guy Nicholson, Head of Zero Carbon Grid Solutions at Statkraft in the UK. With over 4 decades of expertise in renewable energy, Guy discusses the evolving challenges and opportunities of the UK zero carbon transition, including innovations in grid stability and understanding how Statkraft is positioning itself to lead this transformation. Guy, thank you for joining me today. This is an absolutely amazing office. You're quite privileged to work at, just so the audience know, we're on the 19th floor of 22 Bishopsgate. Is that correct?
In London.
In London, yeah. So we're looking over the skyline. We can see the walkie-talkie. I've got the Gherkin. We've got the Lloyd's building. It's beautiful.
Great. It's not my normal place of work, mind, but I'm here, a few days a month. So I'm working from home in the north of England. Otherwise, yeah.
Brilliant. I heard a really good podcast the other day, and there was quite a well-known director talking about the keys to success. And he boiled it down to 2 key areas. He said, it all comes down to passion and purpose. And I kind of just wanted to know if you would agree with that.
Well, it definitely helps, that's for sure. I don't know, what does success mean? Obviously, building stuff, getting stuff done, making stuff happen is success. In terms of the climate crisis, we're a way off success, aren't we? We need to do a hell of a lot more. So I'm kind of a bit schizophrenic about success as a word in that sense. But I mean, I think, when you're recruiting people, when you get people working for you, most of what counts is their enthusiasm, passion, as you say, purpose, drive. Other things will fall into place.
They do. I'm going to laser in on those 3 words actually, but I really want to know about you. So let's talk about passion. What are you passionate about? What drives you and gets you up in the morning?
Going out in the garden. That's definitely one of the first things I do when I'm at home. And like to grow stuff. So, but in terms of work, it's about renewables, it's about decarbonisation, it's about the whole climate issue, and that's kind of the driver for me.
I was going to pick on 2 bits there because I really like what you've said. I actually love the fact you said gardening, because I often, people on this podcast will hear me say that sustainability starts from home, and the core values, the things that we enjoy at home, the things that we're passionate about, often bleeds into our work. So it's interesting to hear that you're a keen gardener. But what led you into sustainability? Let's kind of go back about you and sort of learn about why you're so passionate about the climate crisis and obviously clean and renewable energy.
Yeah, it's going back quite a bit now. So, and I guess I go back to teenage years of, things like the oil crisis, where we were kind of had power cuts and candles occasionally and things like that, and going, oh right, what is this? What keeps the lights on and all that? And then taking an interest in that, and then I guess at the time, oil was running out. Sadly, it hasn't. That's been the real twist. If it had run out, it'd be a lot easier, but it hasn't. Keep finding more of the stuff and gas. And coal, so it's a kind of poison chalice. So I guess taking an interest when we were told that oil was going to run out, and go, what's going to replace it? How will the lights go on? How will we get around? How will we heat our homes and all that? So started reading about that, and I guess one of the seminal books was Amory Lovin's Soft Energy Paths. I think he's now the Rocky Mountain Institute and So it's still going strong in that regard. So yeah, I think the kind of prevailing wisdom was that nuclear was going to provide all the energy. Well, that was the kind of mindset, and I kind of read about it and thought, no, I don't think that's going to happen. I don't think it's what we should be doing. So hence getting interested in renewables, which were, in those days, you were a complete crackpot. Used to start working, I'm developing wind power, and people would just laugh, because wind turbines were very experimental in those days. So, but the technology's moved on, hasn't it? And now turbines are 2,000 times bigger than the first one I worked on. So it's great. So the technology's marched on, and now it's what everybody wants to be in. So it's great.
I love it how you explaining and giving me detail about your journey kind of answered the purpose question at the same time. Seeing this need for the reduction of digging up oil and gas, and it's a finite material, and that gave you this drive to learn about alternatives. And I'm sure we're going to kind of go into that later on and understand about the different places you've worked and what you're currently doing at Statkraft. But I'd like to jump on Statkraft now, actually. This will probably be a good opportunity for anyone listening to this is to explain, who is Statkraft? How did it start?
Good question. Well, we're the largest renewable energy generator in Europe, mainly through our Norwegian hydro. So the company owns a lot of hydro in Norway. It's state-owned by the Norwegian government, and it's got plans to expand. It is expanding and developing renewables, wind and solar, and energy storage, and the sort of stability projects that we're doing on a pretty global basis, but not everywhere in the globe, but a lot of places, South America, India, a lot of the European countries. We're kind of very committed to developing more renewables.
Incredible. And I've read on the website that Statkraft has been making clean energy possible for over a century. So where did it start 100 years ago then?
Well, I guess, that goes back to the Norwegian hydro, and, I guess there's a whole story around that, which I'm probably not the best person to talk about, because you really want to talk to somebody Norwegian about that. But, it's very much part of the culture in Statkraft, and most of our business is running these hydro plants and developing them. And that comes with looking after the water courses, it comes with looking after the environment, comes with looking after the fisheries. So there's a kind of quite a sustainability theme going on there with that whole ethos, I think, of around Statkraft, and that kind of rubs over into other stuff we do.
Sure, and in terms of the mix now, I'm interested to jump on hydro, and I know that's not what we're going to talk about today, but the only reason I'm interested to talk about hydro, because in terms of the mix, it's the one that gets talked about least, especially in the UK. But I was just wondering, for my own curiosity, what part does hydro play in terms of the renewables right globally, or even in Europe, I suppose?
Well, it's, if we go back, really, hydro was one of the first power sources that was exploited, along with coal. So hydro and coal were sort of vying for the first electricity production. So I think the Northumberland, Armstrong at Rothbury built the first hydro-powered house, and in maybe Britain, the world, I don't know. It goes back to the roots of electricity production. And if we look at Scotland, then a lot of the Scottish grid was built around hydro, and the rural electrification in Scotland was all linked to exploiting the hydro. And that all went on in kind of during the war as well. So the Second World War, that was. So, that was quite a commitment of resources. So it kind of shows what can be done when you've got a mindset to do it. In modern parlance, the decarbonisation that we're going to do now is really all about wind and solar. Hydro will form part of it, but the bulk of the heavy lifting is wind and solar, and increasingly solar, with the lowering costs. So that's where the kind of real action is. Hydro is great because it provides that a bit of storage, There's some of the stability and so on. So it's very complementary with the wind and solar.
We would be having a very different conversation now, wouldn't we, if hydro really took off all those years ago and coal wasn't so convenient and cost effective, and it would have been great if we had gone in that different direction. But I suppose we're here now, and we're looking at what can be done now. So let's go back down memory lane a bit. I've got a few points here about your journey into renewable energy, but we're going to look at grids today, and looking at you early on in your career, looking at new power systems. I don't know if you want to touch on that at all.
Yeah, so I guess when I started, there wasn't really anything happening with grid-connected renewables. The renewables were tended to be kind of off-grid, remote, be it for lighthouses or telecoms masts or those kind of situations. And then I was lucky enough to go to the island of Fula off Shetland and put in the first power system on the island of Fula. So it's kind of 15 miles west of Shetland. It's pretty remote. The project had been kind of partially installed. I went there to commission it and finish it off. And, the islanders were going, well, why have you brought all this wind turbine and this hydro plant? We just want a cable from Shetland. We've got some nice big diesels. Why can't we just have a cable from Shetland and some diesel power? Why do we want this new, this stuff? And I think by the end of it, they were, kind of proud that they had a system that ran on renewables. And so I spent the best part of a year on the island kind of finishing off building this system, commissioning it, writing the control software and learning how to run it and operate it and dealing with the teething problems. And that was everything from the mechanical engineering to the software to the electrical engineering. So it was really good training ground. But I think the key thing from that is that with just one wind turbine, a small hydro plant, a diesel. In those days, we didn't have kind of battery and inverters and the technology we have now. So that plant, we ran it on about 95% renewable energy for, a 6-month period. And that most of the time you're running it with no diesel at all. You're just running the diesel when you've got low winds, which was very rarely, or sometimes high winds because you couldn't run the turbine because it was too turbulent or windy. So it was a great kind of lesson in what you can do with a power system.
That kind of built the foundation really of early on in your career, of the knowledge that's taken you where you are today. But talk to me then the sort of stages of where you went from there, and how did you end up doing what you do today, basically?
So when I finished that project, then I wanted to change. I'd done a year on a remote Shetland island, so I think I'd got that out of my system. An opportunity came up with a developer for what was in those days the first wind connected projects in the GB grid through the NOFO, non-fossil fuel obligation. So privatisation came in, going to get the wrong dates here, but around about 1990, privatising the electricity system. When the accountants went in, they couldn't privatise the nuclear because it was too expensive. So then they had to create a subsidy scheme for nuclear, which was called the non-fossil fuel obligation. Because although everyone had been told it was cheaper, and it turned out when the accountants went in, it was actually twice as expensive or more than coal in those days, really. So the non-fossil fuel obligation came in, and some of that was allocated to renewables. So I was involved with a developer developing some of the first wind projects in the UK, and built the largest wind farm in Europe at the time. Don't ask how big it was now. It's tiny, but 103 turbines. So it was with a company called Ecogèn. So that was my first foray into grid-connected renewables. And from there on, I ended up setting up my own company, Connect, which developed in Northumberland and grew over around about 12 years to doing consultancy work primarily in connecting renewables to grid. So we were really supporting renewables developers in getting their projects connected to the grid and dealing with the distribution network operators primarily at the time, or increasingly as projects got bigger with the transmission companies and with the TOs and National Grid as the system operator.
It's amazing because you've had such a varied career in terms of working on smaller projects to the global projects to being sort of running your own consultancy, but now grid manager at Statkraft. So you've kind of seen it from multiple different angles, at multiple different levels. Where do you see yourself as being the most productive? Where and when do you do your best work?
Yeah, I think I'm probably someone who's a bit of I use the word innovator, but I kind of like to find the new things that are the new challenges that are coming on. Once things get up and running, I'm not so much an operational guy. I want to pass that on to somebody else and who do it better than me. I guess pushing the boundaries is always where I see myself, and
I think of it like a Venn diagram in terms of innovation, and I find the innovation is when two circles or a few circles overlap, and I find that and would you kind of do you think like an engineer or designer, or do you think more like a planner? Where do you kind of, because you're quite a hard person to pin down in terms of what you do, but how would you describe your role?
So I kind of come at problems, from an engineering perspective, but it's more of an intuitive engineering perspective in some ways. And my colleague Dr. Jason Hill, great. He's brilliant on the maths. So if I come at something intuitively and he comes at it mathematically and we come up with the same, conclusion, then I'm really happy. But yeah, I'm not a great mathematician, so I sometimes need, that kind of engineering modelling studies doing to kind of ground what I'm thinking.
Well, that's the exciting thing about the space, isn't it? Where engineers, designers, researchers, scientists, and obviously policymakers are coming together to push things forward. And that's why the green economy and working in the energy and renewable space is an exciting time. I suppose there's tons of opportunity in this space, but what is it you love most about working in this space?
People, I think. Just some great people to work with, and I think seeing people learn and develop is phenomenal, and go on to work with a lot of people over the years, and it's great to see them all out there doing this stuff. Probably better than I do.
It's a blessing and a curse, isn't it, with sustainability, because it's a difficult industry to work in, or I don't know if it's an industry, it's multiple industries, but because we're working on something that's quite hard and it's heavy, but at the same time, it does drive people to do great work, because it's much more than making money. It's much more than career development. You're trying to ultimately save humanity, which is a heavy weight on everyone's shoulders.
Yeah, I think it's huge collaboration. Take the work we do here. You've got your engineering side of it. You've got to get a project ready to financial close. You've got to bring all your financial modelers along, your bean counters, your number crunchers. You've got to get the community on board. You don't want the local community being anti. You want them for you. You've got to go through the planning system. You've got to go through your grid connection. You've got to deal with the landowners, farmers. There's a vast array of people involved, and skills and talents, from legal to everything. So I think it's that kind of huge collaboration of people and skills to get something over the line. It's an incredibly complex beast, really, getting a project into operation. Yeah.
That kind of narrative comes up again and again in these conversations, and something that I just want to pick on, and I think it will come to that at the end of the conversation, about public buy-in and trust, because that's something I really care about, because being in comms and communications, and which then kind of overlaps into community engagement. I think it's such an important role in and I always say this, getting everyone on the bus. Just a few things I want to pick on. We often are going to be talking about grids. For me, grid is like something, it's like the internet. It's a difficult thing to describe, but it would be nice to have an opportunity now to understand what is the grid. For anyone that's listening to this that's trying to understand what the grid is, if you could describe what it is and how it works.
Yeah, good question. A challenging question always, isn't it? I think I kind of start with the system and the network and pulling those two things apart. So, when you think of the grid, you tend to think of the network. You tend to think of the pylons, the wires, the poles, the substation in your street, the cables under your street. That's the network. And connected to that network are, consumers. Here we are, taking power off the grid for this interview to run this office. And somewhere else on the grid are wind turbines, solar panels, hydro plant, battery systems connected to that, feeding power in and controlling it and managing it. So the grid I tend to think of as the whole system. And that, you draw your Venn diagram kind of box. You're drawing a big box around everything. It's the generation, the inputs, the network that moves it from the generators all the way up through the transmission system, down through the distribution system, out to the loads, and all the connected demand on it, be it your EV charger, your heat pump, your lights, your washing machine, whatever it is. So that, to my mind, is the grid system. And that's a complex beast that we all interact with when we switch a light switch or switch a kettle on or whatever it is. We're all influencing that system in some way. So
while you're describing that, in my head, I'm quite a visual person. I was kind of like animating that kind of circularity of how from the production to the distribution to the consumption, etc. We need to, myself included, know more about this. So, we should be teaching it in schools so that we could understand where our energy comes from, how it's used, how can we be more responsible with that energy, and ultimately reduce the amount that we use and use the right types of energy. So I think there's probably much more that we could do in terms of educating everyone about energy consumption and generation.
Yeah, and we have lots of interesting conversations around the family breakfast table, whatever, about the issues and the challenges and these technical terms. But I think that you talk about energy at the moment. Electricity is only a third of our energy comes from electricity or used from. And what we've got to do, and that's the exciting thing about being in the grid and in electrical engineering and renewables, is that electricity is going to grow and replace the fossil fuels. Happening with vehicles, electric vehicles, no longer using petrol and diesel, but using electricity from the grid, charging the batteries up. It's going to be in heating in terms of heat pumps instead of gas boilers and so on. So the transition is moving all that energy that's not electricity into electricity, and that means we're probably going to something like double the amount of electricity that we use and generate and supply in the next 20 years or so.
Let me pick on that again. You mentioned how much electricity that we use and where it comes from. Just pick on that again so that people can understand what that means. So you talked about we only use, was it 20 or 30% is electricity?
Yeah, so, most of our energy is used for heating our homes, which is largely gas. It's used for transport, which is largely petrol and diesel. So electricity is used for relatively, minor things at the moment. So what we need to do is turn all that fossil fuel use for heating, for transport, into electrical use, and that means we're going to have to generate more electricity to supply that.
Right. Okay,
but the great thing is that the electrical use of energy is so much more efficient. Take a heat pump, put a unit of electricity into a heat pump, it sucks 3 units of energy out of the air, or usually the air, to heat your home. So you're using 1 unit of electricity and 3 units of ambient heat from the outside. It's the magic of a heat pump. And puts 4 units of heat into your house. That's phenomenal. In terms of efficiency, it's positive efficiency as opposed to negative efficiency, which is mostly what you see, reduced efficiency. So that's phenomenal. Take electric transport, putting a charge into your electric vehicle battery, use a lot less energy because the conversion efficiency from the battery to the motor to drive your car is a lot higher than putting diesel or petrol in, which then goes through thermodynamic process and most of the heat goes away in the exhaust and the radiator. So, the primary energy use that we have at the moment is actually going to shrink. The amount of energy, total energy we use will shrink as we make more renewables and move everything to electricity. So that's a great, opportunity and a great plus of moving to renewables.
Yeah, the electric economics is an interesting area because when we look at decarbonisation, I always look at it like how we're going to decarbonising as it stands now, but the process of decarbonisation means the electrification of industry, which then would it double or triple the amount of electricity that we need, which is it's paradoxical in the way that you think about it. Yeah,
so you mentioned, and I hadn't mentioned industry. So obviously industry is another one where we want to decarbonise. So, industry, heating buildings, transport, those are the real things that have to be, decarbonised. And people used to talk about hard to abate, carbon emissions, but with all the focus on technology and developments and the low cost now of renewable energy compared to fossil fuels, then that driver is coming there. New ways, and I'm not up to speed with all these kind of new technologies, new ways of making steel without blast furnaces, new ways of making cement, and all these kind of things are starting to get attention and looked at and be addressed. Still challenging, but it's moving in the right direction. So I think in terms of electricity in GB, we're talking about doubling the amount of electricity that we use, and that will kind of replace a lot more fossil fuels. We don't need to generate the same amount of energy as we use for fossil fuels because they're so inefficient. You've got all those thermodynamic processes. When you turn a fossil fuel into useful energy, you throw loads of it away. Whole power stations with cooling towers, that's just energy being thrown away because of the thermodynamics of combusting fuel and turning it into electricity. So, if you can make electricity direct from solar panels, from wind turbines, you don't have those inefficiencies.
I think we'll move on to energy production in a bit because I think that's going to be a big part of this conversation. But on my notes, I have got some notes here, an interesting thing about in lockdown. And because we were talking about consumption and how, obviously, during lockdowns, we saw energy consumption drop. I don't know if you wanted to, and it mentioned here about NG ESO. Had to turn off the wind and turn off fossil fuels.
No, it was really very interesting. It was kind of like jumping the power system forward by a decade, suddenly in a couple of months. And as you say, during lockdown, early 2020s, everything shut down, electricity demand dropped, but we also had, in the kind of spring, we had a lot of wind and solar energy around. And there were several days, the first time it happened, where the electricity market, which dispatches the most cost-effective renewables, was said, well, we don't need any fossil fuels. We've got a bit of nuclear, we've got some hydro, we've got wind, we've got loads of wind, we've got loads of solar. But we don't need any coal, we don't need any gas. So the coal and gas station guy says, no, we're off. It's not economic for us to produce. And National Grid, who operates the system we talked about earlier, the grid system, this whole beast, joined up beast, went, well, that's all very well, market, but we need to run a stable grid here, a stable grid system. And we're used to having these power stations running because of the kind of ancillary services that they supply, system services. So they're supplying things like inertia, voltage control, these technical things on the grid. And the renewables didn't supply the same things and weren't in the same place. So grid went, hang on a minute, we can't run the grid. We need to turn on at one stage about 17 gas-fired power stations around the country. So, there's a huge amount of carbon emissions, a huge cost. And because those power stations can't deliver the services without generating electricity, then suddenly there's too much electricity on the system. And we know you'll have to balance supply and demand. So what do they have to do? They have to turn off lots of wind. So turned off lots of wind to make room for the fossil generation. And that was just for these stability reasons, these services that keep the grid operating and functional and stable. And interestingly, that was 2020, we were already in contract to build some assets that would provide these services, our green grid parks, provide these services to the grid without generating any fossil fuel. So when this happens in future, National Grid won't have to turn off wind, turn on gas. They'll have the services that they used to get from the fossil fuel plant delivered from our green grid parks, so that the grid can operate on 100% wind and solar with whatever else is going at the time.
The green grid parks are a really interesting thing that we can pick up on. Just before we get there, though, we've talked about where COVID accelerated certain parts by about a decade.
So kind of jump forward, and to a degree, it's moved back a bit. Yeah, so right. It was a kind of more of a kind of short-term time travel into the future, and
right. And it's interesting to hear about how we compensate for when we've got too much energy and when we haven't got enough. And I know that fossil fuels, coal, gas, are used to sort of fill those gaps. So I suppose we've had an interesting year. As we record this, we're just coming to the second half of August, and lots going on. We've got an ambitious government that wants to sort of get to fully zero carbon by 2050. What are the biggest challenges we've got over the next couple of decades? Where are the big problems going to come from?
Well, I think the first thing I'd like to point out is zero carbon system operation, or zero fossil system operation, is a National Grid target, and it's a target next year, 2025. So that means 1 hour a year where they might operate the grid without running any fossil fuels. So going back to 2020, the example I talked about, but without having to turn on these fossil stations. So it's a bit of a kind of, I'm going to call it pot luck as to how the system has to just be right for that to happen. The right wind, the right solar, the right demand in the right place at the right time to all sort of be that perfect coincidence of circumstance to allow that. But that's hugely significant, because once that's done for an hour, it can then expand to several hours, to a weekend, to overnight, so on and so on. It'll expand and expand. So the concept of doing that 10 years ago, I remember having to write a riposte to the Irish grid operator. The Irish grid operator, going back into the early 90s, was saying, well, you can't have more than 10% of wind on the grid technically. I'm going, well, I've done it on the island of Fula. So if I can do it on a small island, surely you clever guys, all these engineers, can do it on a big system. And so there was this kind of mindset that it couldn't be done. And that mindset's changed, to it can be done, and this is how we're going to do it. And that's great to see the system operator kind of having that target in the UK, in GB rather. So, the first step is, can we get 1 hour of zero carbon operation, and then that will expand and expand. And so, 2030 is the Labour government's target, to have a decarbonised electricity supply. So in my book, that means kind of, going back to the island, 95% of the time. We might have to run some fossil fuels occasionally when there's a dunkel flout, as they say, a low wind, low sun kind of period.
Is that a Norwegian term?
It's German.
Oh, right.
Yeah. So it's a great word. I love that.
What does it mean?
It just means a very calm, cloudy, murky, dark period, not like today. We're talking about, February or something,
Right.
when it's overcast and there's no wind. So you don't get solar, you don't get wind. You've got that challenge of those, renewables gaps. But, my view, if you need to retain some fossil fuel on the system to ride through that, so be it. We're about decarbonising, reducing the amount of fossil fuel, not being kind of purist and saying we, have to have zero. It's about where is it most economic to kind of address fossil fuel emissions. So in my view, you want to get to like 95% zero carbon electricity grid in 2030, and then expand it, double the amount of electricity, push out fuel from industry, push out fossil fuels from heating homes, buildings, push out fossil fuels from vehicles and transport. That's the most efficient way of spending your money. Then, by the time we get to 2050 and we've got virtually all our energy through electricity, then we'll find ways of squeezing out the last bit of fossil fuel from that.
Do you call it Dunkelflaut?
Dunkelflaut.
So what do we do when we have Dunkelflaut in 10 years' time, when we've turned off the power stations, the coal and the gas? When we have a Dunkelflaut, how do we make steel and how do we power our homes?
So Dunkelflaut, it's not zero wind and zero solar, but it's low levels. We've got increasing amounts of interconnection. So, you get a Dunkelflaut in one area, you don't tend to get it in a wide area. So you can move electricity around on interconnectors. We've got increasing amounts of storage. If you look at Norway, stores enough electricity to power the GB grid for several months. So we've got increasing amounts of battery storage coming on, which isn't going to last for a week or 2 weeks of a Dunkelflaut, but will help the process. And then, we, in my view, will retain some fossil fuel to get us through that. Some kind of power stations that sit there idle for 95% of the year and just run for these occasional periods. That's my view of what will happen. It might not be, purist in terms of we've got to have 100% renewables, but yeah, that's what I think it means.
Where does nuclear sit in this narrative?
Massive distraction, massive cost, massive delay, massive waste of resources. Nuclear is so expensive, and it's so slow. Look at Hinkley Point. I was just pulled out a newspaper article the other day saying from the head of EDF saying EDF was going to cook my Christmas turkey in 2017, and where are we now? 2024, and when is it going to get built? So it's just too slow as well as expensive. So we've got a shortage of engineers and technicians and contractors and resources. Why are we having them build something that's too slow and costs shed loads of money? Just doesn't make any sense. But UK has a fixation with it.
Can we speed it up and make it more cost effective?
No. I mean, how long's it been going? How long have they had? When we started building wind turbines, we've increased them 2,000 times in size. Probably, in terms of efficiency, energy production cost, levelized cost of energy. You've seen the curves that come down, the learning curves. Phenomenal. Solar, it's just massive learning curve, massive cost reductions. Nuclear's been on the books for
50 years,
70 years or more, something like that. Since after the war, the first Magnox projects, Magnox power stations in GB, and they've had all this time and they haven't. There's always talk about small modular reactors and stuff. It's all just moving the deck chairs on the Titanic for nuclear. It's crazy nonsense, and the sooner we forget about it, the better. But that seems to be impossible in the UK's DNA for some reason. Yeah. Okay,
interesting debate there. Okay, well let's talk about grids, because that's what we're here. That's what you do. Let's talk about your role at Statkraft now. Then let's talk about your role now. What your core objectives and what does the future look like? Where are you moving?
Yeah, it's. I think, we've been through the stability pathfinders. So National Grid in 5th of November 2019 launched its first tender for stability pathfinders, and that was for inertia on the grid. So the rotating machines, generally the gas and coal power stations, all connect to the grid with synchronous machines. So they have these big spinning electrical machines, big spinning turbines, sort of steam on the end of it, or water if you're a hydro plant. And that's all connected to the grid, and that provides inertia. So if you get a big disturbance on the grid, like a power station trips, that supply, I'm going to get the microphone in the wrong place now, that supply generation balance goes out of kilter. And what happens is that the inertia in the grid, the energy in the spinning mass, is fed into the grid, and that makes up the difference between the two things, between supply and demand, levels them up. So that inertia is crucial in managing the frequency of the grid when we get these big disturbances. People think or some people have thought it's to do with the fact that wind varies or the solar, the sun goes up and down. No, that's not it. That variation is tiny compared to you've just lost 1.5 gigawatts of power coming across on an interconnector. Suddenly the GB grid is short of, 5% of its inputs because you've lost a big feed in, and that's the big challenge that the grid has to deal with. And the inertia really helps you survive that. Otherwise, there'd be a blackout. So what inertia does is it kind of slows down the change in frequency. So if you've got a high inertia system, when you get a big disturbance, the frequency will change gradually. And that gives you time to go, oh, frequency's falling, let's respond. And by the way, batteries are great at that. They can see the frequency falling, push power in to get the frequency back up, get that lost power replaced. If you have a low inertia system, that frequency falls really quickly. And then potentially you don't have time to respond before the frequency's gone too low and everybody's, it starts turning or disconnecting load, or worst case, blacking out the system, if things go badly wrong. So inertia buys you time to respond when there's a big event, and that's what we did with the stability pathfinders. We provided these synchronous compensators, which are heavy rotating machines, but with no fossil fuel attached to them, and they're just sitting on the grid, providing that inertia to the grid.
Talk to me about those stability pathfinders. What are they? What do they look like?
You mean in terms of the physical assets?
Well, how do they operate?
Yeah, so what they are is if you go to Keith or Lister Drive, one of our greener grid parks with the rotating stabilisers, or Swansea, which we're building at the moment, you'll see sheds with a big electrical machine inside it, and quite often with a flywheel associated with it, or a large mass. And so, you go into the door and it's quite noisy. You want some earplugs in, really, because you can hold a conversation, but it's not that pleasant. And these machines are spinning around with the grid, and you think, well, what is it doing? So, and it's just there, sitting there, most of the time, waiting for that event on the grid to happen, which might be, you get one of these large events, maybe once a week, twice a week, and they last for a few milliseconds or seconds, and then you're back to normal. So most of the time, so you're not likely to walk in there and kind of see what they do, or feel what they do, or hear what they do. You've kind of got to record that and look at the data. So that's their inertial response coming in, and so I say it enables grid to have these machines on and not have to run a power station with fossil fuels.
And they're based at the greener grid parks?
And there are greener grid parks, yeah.
Talk to me about that.
So our idea with the greener grid parks is that we build these assets there we get our grid connection, we use that for different technologies which may evolve over time, as needs on the grid change. So, we're building our first batteries at the moment in our greener grid parks, and we've seen batteries move from, they weren't on the GB grid, 6-7 years ago, very new onto the grid. They've been a massive benefit to cost of providing frequency response. I say, when the frequency gets imbalanced, the frequency drops, and batteries are really good at detecting that and quickly pushing power into the grid and bringing the frequency back. They cut the cost of that frequency response in about a third when they came in, and now I would say it's almost down to 20% or less of what it used to cost. So this sometimes there's a myth around that renewables cause huge costs on the grid. Well, actually no. Batteries and frequency response is a great example where they've actually cut the costs of running the grid. And if it wasn't for renewables and the renewables industry and that technology and those capabilities, nobody would have either thought or been able to deliver that. So renewables has actually brought on these lower costs of system operation as well as lower cost of energy. So that's one of the myths I'd like to take an opportunity to dispel.
Yeah. So the greener grid parks, there's this lofty goal of contributing or operating at a zero carbon electricity by 2025. Is that on target?
Well, I think it's a bit luck as to whether it'll happen in 2025, but 2026, yes. When we're still bringing on greener grid parks in 25, 26, and so are other people bringing on similar technologies. So as those projects in the stability pathfinders get built and rolled out, that will give National Grid as the system operator, or should I say the electricity system operator, because they're divorcing themselves from National Grid, the ESO chance, more tools in the box to enable that. And so we'll get more and more periods. I don't know if you remember coal, there was a celebration when we had our first coal-free hour, and then our first coal-free day in the GB system, and then the coal-free weekend, and so on. And that was kind of totted up. You can see charts of how we've moved from being completely reliant on coal to moving away. And later this year we'll have no coal left on the GB grid, which is amazing considering it's been the mainstay of the grid. So it shows how quickly things can happen when you get the right tools and momentum and things in place. There's a massive team of people doing this.
There is. It's a network activity, and we touched on that earlier, the different types of skill sets and minds and aspirations you've got to get around the table to move these things forward.
But just in terms of our greener grid parks, we're talking about energy storage and batteries. So when those first projects came in, 6-7 years ago, I was involved with one at Tynemouth, delivering this enhanced frequency response. That was a half hour of energy storage. We're now building 2 hours. We're planning on 4 hours, 8 hours battery storage. The costs of batteries are coming down, so there's, I'm not going to call it long duration, but those longer duration storages are coming, and that will make a massive difference in the system. I've seen it in California recently. Massive input of batteries pushing gas off the system, reducing fossil fuel use. So California, they're taking solar energy that's produced in the afternoon, storing it and providing it back for the evening peak demand. So, helping manage a massive more renewables contribution to the grid. And we're going to see that more and more here. We're already seeing batteries being used more and starting to replace or displace the fossil fuels.
As a company, a global company positioned right across the globe, does this help you in terms of positioning, in terms of actually driving the technology forward because of the different landscapes and the different climates and the different political structures of different countries, that you're able to knowledge transfer, bring technology across where maybe an organisation that primarily works in one country doesn't maybe have that kind of facility or network? How's that driving Statkraft forward?
Yeah, well, definitely, that kind of knowledge sharing across the business is certainly key, and is great because we did our first batteries in Ireland, and we're now doing batteries here, and then we're looking at batteries in other European countries and South America. So the knowledge sharing is key. I'd take hydro for example. We're developing Loch na Carrach, a pump storage hydro project in Scotland, and that's gets all the expertise from what we've done in Norway and Albania and India and so on. So South America. So the hydro expertise is key to us being able to develop a large pump storage hydro project here in GB. So yeah, that knowledge sharing is key. But I think you talked about the political side. I think it's in terms of what I'm involved with, it's much more around the regulatory side, I think. And I always say the physics is the same wherever you are in the world. The electrical standards, the international standards, IECs, the Euro norms, generally the same. When it comes to the kind of custom and practice of what happens, how things get done, it's massively different. Even in GB, you try and deal with the 3 different transmission owners in GB, and you'll have a completely different experience with each one. You think you've done something with one transmission owner, I'll just do that with the other. No, they don't do it that way. So, there's a bit of a myth that we have a GB kind of market in that sense. We still have these kind of regional kind of rules and fiefdoms that kind of make it challenging to do projects. But you go, to other countries and other regions, and that's even starker. So I think the great thing about GB is that we are pushing the markets for ancillary services or system services, hence the system operator having these stability pathfinders. Other countries would just say, we'll let the transmission system operator build those assets. We won't go out to competition. We won't have a market for that. And, that, or, you go to kind of Australia where they go, well, everybody's got to build one of these things. That's hugely inefficient. You really want these kind of key strategic assets at strategic points on the grid. You don't want them at every power station or every interconnector. That's just duplicating resources and wasting in investments. Yeah. So, I think for all its I'm highly critical of the GB regulatory system and the way we manage the whole grid and how that works, but we have a kind of concept of putting things out to competition and markets, and that's great that we do that. And the ESOs to be congratulated on running these tenders and competitions, and that just drive innovation. It drives down cost, and it really helps bring in renewables. Amazing.
Yeah. So I'm respectful of your time. So I'm going to, before I bring this sort of conversation to a close, I want to touch on something we spoke about earlier about public buy-in, community development. Obviously, I mentioned we've got to get everyone on the bus here. We're making decisions for everyone's lives now and in the future. Where are the biggest challenges that we have, or what recommendations do we have in terms of engaging the general public to, one, create awareness and education, but to allow them to make better choices in terms of what they do day to day?
I think in terms of the day-to-day, I think that the sort of dynamic pricing, or people call smart meters, not that smart, but they measure electricity every half hour, that kind of time of day pricing that some of the suppliers have brought in. I think we need to have more of that, and then we need to educate and encourage people to be able to use that to lower their electricity costs. So I think that's important. So we send the market signals to help drive consumer behaviour. But I guess in terms of where it impacts, our projects, it's more about the local communities to projects, and it's important to really engage with them, talk about what it is we're doing, explain it to them, and that takes time and energy. But Statkraft is really good at that. We've got a dedicated team that engages with communities, and we have some of our some community benefit funds from our greener grid parks, and they're targeted at helping decarbonise and helping people to do those kind of local projects. So that it's just about taking the time and effort. But you do run against communities where you've got maybe one or two people who have kind of got a bee in their bonnet and anti. Sometimes there's a number of developments going on in an area which kind of coincide, and that makes it more challenging, especially as we're trying to accelerate the process. It does mean that things kind of come faster, and sometimes there are multiple projects coming along at the same time, and that's hard for communities to get their heads around, I think. So,
and you mentioned being trust and transparency and speaking with people and meeting people where they're at, having conversations.
Exactly.
Yeah.
And at the end of the day, I think the other challenge is that what you find is that you've got support in a community, but people aren't actually going to turn out and demonstrate to support your project. But you might get one or two who will try and demonstrate against it. So it's trying to understand that balance in the community. That it's hard to persuade everybody all the time. You do your best, but inevitably you might have some people who can't be persuaded. I think I tell you what it brings up to mind is wind, because when you ask people about wind, they say, oh yeah, we support it. And then you say, well, there's going to be a wind farm in your local area. And what you find then is support goes down. And then once the wind farm's built, you find that the support goes up. So it's higher than it was before the turbines came there. So they go, actually, we really like them. See them go around, we can see which direction they're pointing, they're interested in the landscape. So I think that's going to be the same with, most developments, that people will say, yeah, well, we weren't sure, we didn't like it, but actually it's not as bad. I mean, actually, Bewley-Denny, with the new transmission line was an example. I had friends who lived near Bewley-Denny, the transmission line in Scotland that were upgrading a few years ago, and they kept asking me about it. And then I went back after it was built, and they went, well, what was all the fuss about? Actually, we hardly notice it. It's not much different to what was there before. So these things can get hyped up sometimes out of perspective. So
yeah, it's all about perspective, isn't it? And perspective changes once people see the turbines go up and the parks go in, and they can see the benefit of them. And I think they look beautiful. I think most people get used to them. I think we've had windmills in this country for a long time.
We used to have hundreds, didn't we?
Yeah,
or thousands.
Not as big as the ones we've got now, but they still play an important role. If people want to find out more about you, I know that you write articles and you're online. Where can they find out more about you, Guy?
About me, I guess. I'm on LinkedIn. I'm not very good at it. Obviously, you can go through Statkraft's websites. Our greener grid parks are all on the website, and there's contact details there if you want to know about a particular project. The other thing we're keen to engage with is local supply chains when we're building projects. So we try to encourage people with services. There could be all sorts of things from accommodation for workers to, security services to contractors of all natures that go to build a site. There's a huge amount of local involvement and skills and to deliver one of these projects, and we rely a lot on local contractors to do that. So there's a good links into our greener grid parks there to make contact and get on the kind of supply list.
Great. And anyone that's listening to this, we can put links to that. We can put links to different parts of the website, obviously links to your work and yourself. But yeah, I just want to say thank you for today. or champion, as you would probably say. But it's been really interesting, and I've learned loads, and hopefully we can do this again soon. But yeah, thank you for your time.
Jonny, thanks for a great conversation. Really enjoyed it.
Amazing. Thank you.
Cheers.
Thank you for tuning in to the Energy Futures podcast. Here at Energy Futures Lab, we are dedicated to addressing global energy challenges through pioneering research, innovation, and advocacy. To learn more about us and the exciting projects we are working on, visit our website and follow us on social media. If you enjoyed this episode, please like and share and subscribe to stay up to date with our latest content.